Let's look at to the second example for the two asset case. So in this one we have the two asset portfolio. In the first asset Microsoft stock we have 10 million position, and the second IBM stock we have 5 million position. And suppose that we have already calculated the correlation coefficient between the returns of these two stocks is 0.3. And here we have the formula to calculate the portfolio standard deviation, which is denoted by sigma x plus y, meaning that we have these sum of these two positions. And in the first asset, suppose we calculate the daily standard deviation, which corresponds to this 200,000 US dollars. So that's the standard deviation per day. These inputs are already given in this example, but if they are not given, basically we need to use the data, use the historical data to calculate the sample standard deviation for each of these assets. And then we can multiply the standard deviation that we get from the log returns with the notional position of 10 million and 5 million respectively for these two stocks. So that would give us these sample standard deviation in each position. So for the portfolio standard deviation, you can see we have the correlation coefficient. Again, this can be directly estimated from the data using the sample correlation coefficient. Assuming these are all already given in this example, so you can simply calculate the portfolio standard deviation as 220,000 per day. So if you calculate the VAR for the given 99% confidence level, we are working with the 1-day time horizon. So you multiply these two numbers. So notice that this 2.33, this is the critical value from the normal distribution. So how can I verify this critical value? So in MATLAB, if you use norm inverse function for, let's say, 0.99, so you can see that by using the inverse of the normal CDF function with this confidence level, you can get this critical value that you will use here. So when you use this critical value, that means implicitly you already assumed the returns are normally distributed. So that's why this basically VAR is coming from the normality assumption. So if you want to convert this to the 10-day VAR for the same confidence level, by our convention, you can multiply this by the square root of this 10 days, and that will give you the value at risk for the 10-day time horizon with 99% confidence level. So this means 99% of the time our worst case loss will not exceed this number, right? That's what the VAR will tell us. So now let's look at the multi-asset case, which now you can generalize to as many assets as you like. So in this case, you will need to know what's the investment weights into each of the assets. So here, suppose that we are given the covariance matrix for all the assets in our portfolio, and in this example we have 3 assets, but as I mentioned, you can extend this to n number of assets. It doesn't change the way we calculate the VAR here. So suppose this is given, or you can again estimate this from the historical log returns data if you have the data for these 3 assets. So suppose we have this total investment of 10 million in these 3 assets with the given investment weights here. So how do we calculate the value at risk? Again, suppose we are using the normality assumption. So you need to calculate what's the portfolio variance by using the W sigma W transpose. So this gives you the portfolio variance. And I have already written these coefficients in MATLAB here. So this is my investment weights, and my covariance matrix is given here. So if I calculate my portfolio variance, this is what I get. And then simply you can take the standard deviation, you will calculate this standard deviation. And one thing that we need to be careful, this covariance matrix, these these values are denoted in annual terms. So since these are annual terms, our portfolio variance is standard deviation is also calculated per annum. So we need to convert this to the daily by using the by dividing by the square root of 250. That there's some small typo here, but this will correspond to 1.35% daily standard deviation for the whole portfolio. So once I calculate this standard deviation, I will multiply with the notional amount, and I should also multiply with the critical value that corresponds to the 95% confidence level. So okay, I can also use non-inverse function, so we can see that the critical value again can be calculated using the inverse of the normal CDF function. So in MATLAB we can use norm inverse built-in function to get these critical values from the normal distribution. But if you are using, if you don't want to assume normality, you can utilize other distributions, but in that case you will need to use the inverse of the CDF for the other type of distribution if you don't want to assume normality in this case. So this gives us the value at risk for this multi-asset portfolio example.